All right, recording should be underway. So good morning again, everybody. We are going to take the continuation of what we were doing last time. If I can get my slide control there. There we go. All right, so last time we started with module one. We just had a little bit of time to go over the introduction stuff for module one. So like the logistics, stuff like that. So I'm going to leave it in the PDF that I'm going to upload for module one today, simply because that way it makes it easier for people to find, this kind of information here, like for example, the learning assignments that we're going to use and stuff like that. Okay, learning activities, sorry. So I'm going to keep those slides in the PDF for today so that the rule is always go to the first lecture at the start of a module, and you'll find the list of all the activities that we have there. So we discussed last time about the concept of building block in programming, right? And I compared that to playing chess a little bit. So I hope that you guys have a good idea now of what you're like stepping into, okay? So that means, just to recap real quick, the important stuff, that means two things, right? That means that learning the building blocks of programming, what we're going to do today, learning the syntax of the Java language, what we're going to do, all along the two courses on Java. That stuff is easy. It's really easy. Okay. If anything, you could brute force it into your brain. You could memorize it, force it by using index cards. I don't know, whatever you use. If I gave you like 30 dates in history to remember and the event that correspond to them, how would you memorize that, right? It would like force it. You would actually use rote learning. Well, you can use rote learning for syntax. You can use rote learning to a certain extent for the building blocks. So that's the good news, right? The bad news is that if you are even like 90% okay with this base knowledge, right? It's like a chess player saying, well, I can move all of my pieces except those four pieces here on the side. So what that's going to cripple you for during the games, right? Same thing with programming. Is a syntax. If you are constantly wondering, how do I write this in Java? You're not going to be able to translate your IDs, no matter how good the IDs are. Okay, and if you are constantly forgetting, what are the 5 or 6 things that I can do in a program, you're going to feel lost. Not only you're going to waste time, right? But you're going to feel lost when you have to write something. So let's go over those building blocks. Okay, let's try to make them very, very super clear, very solid. Feel free to interrupt me anytime you have questions. You know the drill. Okay, I really want this stuff to be solid, and you should not have to spend too much time outside of class, studying for those. They should be kind of like you're already 90% there after we're done with the lecture, and then just a reread of the chapter or something like that, and you'll be okay. All right, so what are the building blocks that we are going to cover? So we're going to start with building blocks number 0. It's number 0 because it's really the most trivial building block that I could think of, okay? It's a sequence of statement. And the good news is that we already covered that building block, okay? I told you about my habit to kind of introduce things a little informally beforehand, then we cover them officially in the slides, then we keep using them, right? Well, we already introduced informally the concept of a sequence of statement. We have been using it all along in our code, okay? So the idea is you have a bunch of statements, one after the other. You execute the first one, you execute then the second one, you execute them all in order. And there are two new things that I need to introduce. Inside a block of statement, you can find a statement, multiple statement, but each of those statements could be itself a block of statement. So you can have a block of statement inside another block of statement, okay? And then the second thing I want to introduce that's new is the idea that some statement, like the statements that we have been using, I would say most of the time I've been using statements that are kind of atomic, right? System.out.println hello world. Well, there's not much to say about that. It's like I'm calling a method, right? Okay, but there are some statements that are going to be composite. So that means some statements are going to contain blocks of statement themselves. So you see the picture, right? A block of statement delimited by the curly brace can contain atomic statement, can contain blocks of statement, can contain statements that are going to be composite and themselves contain one or more over block of statements. Okay, so this is how it's going to look like. you've seen this example already. You know, we have been putting like a bunch of statements already between curly brace like that. They get executed in order. That's what we have been doing until now, okay? What I'm saying with the previous slide is that the same code here that does system out println of 1, 2, 3, 4, 5, and 6, I could have written it like this. There are many, many different ways I could have written it, right? But this says, first, you do a system.out.println1. Okay, that's the first item in this block of statement that starts here with this curly brace. Then open another block of statement inside the first one. Do system.out.println2, close that block of statement. Open another one, still inside the first one, the outer one. Do system.out.println3, 4, 5, and then the last thing I want you to do is open another block of statement, do println 6, and you're done. So I have to be careful with the indentation. I have to be able to match, reliably the opening, closing curly braces, etc. But this is going to work just fine. Java is okay with this. All right. So it's going to execute that and do what? Well, here's a block of statement. Execute the first instruction statement. Sorry, system.out.println1. The second statement is itself a block. So again, it's a block. So go inside, take the first statement, execute it. System.out.println. Is there more? No. End of block reach. We're done with that block. Start a new block, 3, 4, 5, start a new block, 6, end of block, end of block, end of block, and that's it. So is there an advantage to writing things like that? No, hell no. This is like really just to show you the syntactical rule and show you what Java is okay with from the syntax point of view. And this is going to come handy at some point, okay? At some point when we talk like in the second half of the course, when we talk about variables, this notion of you can have blocks of code everywhere is going to become actually relevant. But for now, yeah, this is just like showing off, that we know the syntax for Java and the rules for Java, but it has no practical utility for us to go with the left side version of the code rather than the right side version of the code. I just want you to understand that from the Java perspective, these two things are equivalent. All right. We have been using blocks of code as the body of methods, like our main method, always after the header of the method, right? We are going to define a public static void method named main, and these are between parentheses the parameters it takes. That's the header of the method. And then right after that, we just slapped a block of code delimited by curly braces, okay? And that was where we put the code that is actually the body of the method. So it's kind of like slapping a label, public static void main, string, etc. I put that label on top of that block of code. So it's kind of like having a named block of code. That's what we have been using method for until now. But we're going to do much more with them, okay? So we have been defining additional method, and every time we define a new method in our class, right? We just add it before or after the main, it doesn't matter. I mentioned that already. And we go again, public static, always. Void, we are going to change that very soon. Public static void, my method, a pair of empty parentheses, and then after the header of my new method, when I declare it, again, a block of code that represents the body of the method, okay? So just a reminder on the syntax, there are two things that you can do with a method. You can declare it. So this is this part where we give all that information about the method, the header, and then we define what block of code needs to be executed when that method is called. And the second thing you can do with a method, obviously, is call it, like trigger it, execute it. And this is the syntax we have been using all along. Let me pause a little, chat window question. Would it be wrong to say, would it be wrong to say it like this? Public static void main, blah, 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 put stuff here, close the curly brace. I have always put the opening brace after the first line rather than below. Is that allowed in this course? Yes, that's one of the things we discussed last time, It's one of those where it gets a little too subjective for my test. So you guys can do it whichever way you prefer. You prefer to put your curly brace, like I do here at the end of the line, you're fine. You put it at the beginning of the line to align the curly braces, differently, that's fine as well. I think when you click the auto indent button in, let's check that together actually. When you click the auto indent button in JGrasp, that one here, generate CSV, it's okay with the curly brace opening at the end of the line. And if I do something like this, I think it's going to be okay too. So if I ask it to reindent, yes, it leaves my indentation. It lets you go with whatever way you prefer. Okay, so I don't have any preference. You're not going to lose any points with because of stuff like that. You are going to, however, lose points if, for instance, you don't indent properly your code, like you turn in something like this. Yeah, this is sloppy programming. Okay. All right. So good question. Back to the slides. So we have the syntax to declare or define the method. I'm going to use the two terms interchangeably. And then the syntax to call the method, start its execution. Okay, we have already covered all that. That's why I'm going a little fast. Okay, and that's it for building block zero. Building block zero is just, there are blocks of codes in Java. Sorry, that's the first thing you can do. You can put a block of code somewhere, and inside the block of code, there is a sequence of statements, and they get executed in order. Most trivial stuff ever. That's what we have been using until now. Building block one. So this is new, okay, but not to anybody who has ever written a line of code before, okay, not yet. But this is new for people who never wrote code before. Building block of programming number one is, yes, you can write a sequence of statements, but you know what? Some of those statements can be actually declaration of variables. So for those of you who come from, JavaScript, you still kind of declare, I think, your variable. But Python, you don't have to declare your variable, okay? So this is going to be a little bit of a difference. In Java, a variable, just like in other programming language, is just a name inside of which you can store a value. Let me explain it like that, and then we'll go more in detail, okay? But you say, for example, I have a variable x in math. You say x equals 2. Well, you store the value 2 inside of x. Well, it's kind of the same thing in programming language. I have a variable x. I put the value 2 inside of the variable x. So now every time I refer to x, every time I use x, like if I do, for example, system.println x, then x is going to be evaluated into its value. Okay, we look inside the variable, find the value, and that's what we use. Okay, so the concept of a variable, generally everybody is familiar with it. Okay, if you have used the calculator, there is a memory function, some kind of ID. Okay, what we have to do in Java that is not true in every other programming language is that we have to declare variable before to be able to use them. So you see the syntax here to declare variables. So there is going to be a keyword. So we're going to introduce 3 new keywords in Java: int, double, and boolean. Okay, and actually I'm going to also introduce true and false. So this slide is going to have like 5 new Java keywords in addition to the 4 previous keywords that we learned so far. Okay, so int, double, boolean, they represent data types. Remember last time we talked a little bit about data type. I told you 5 is the value 5 expressed as an integer. The data type of 5 in Java is integer. The data type of 5.0, I told you it's a floating point number. So the integers in Java, we call them int. Easy to remember. The floating point number, for now, we are going to call them double. And that might sound weird, okay? It stands for double precision. So that implies that there are, single precision floating point number in Java. Yes, we'll see that later. So for now, if you want a round number, if you want to store a round number like 42, 23, 9, minus 128, 0 in a variable, you use int. If you want to store a value, a numerical value that has a decimal dot, then you would use the data type double. And then Boolean is true or false. I don't know how many of you are taking discrete math right now, right? But you are going to talk about Boolean value in discrete math as well. In Java, you can say, I want a Boolean variable. This is the name of the variable, arbitrary, and I want to store inside the value true. So there are 2 more keywords in Java: true like this, spelled with a lowercase, and false with a lowercase, and both of these are the values for true and false in Java. Okay, just like 0 is the value for 0, while true is the value for true in Java, but it's a keyword. Okay, catching up with the chat. How many decimal places can a double variable hold? Good question, Shane. I don't know. I don't remember off the top of my head. The double variables are stored on, I want to say, on 64 bits. So part of it is going to be for the mantis, part of it for the exponent. Okay, and we can try to figure out, how many decimal places we get from there, but I don't remember off the top of my head. Sorry. This is nothing that you are going to bump into in this class that's going to be a problem. I can guarantee you that, okay? If we were doing scientific computing or implementing applications that are really math heavy, then yes, that would matter, definitely. Question, so I'm going to take your follow-up question. So when would you use a float? So float is the other data type that we're going to introduce very soon, that is single precision. Well, honestly, I don't know. Not in the context of this class, I don't know why you would want to ever use something else than a double. Okay, that's why I introduce it here. The three data types that I introduce here are kind of like the minimum set of data types that you know to get started doing interesting things. Okay, so with a double, you're guaranteed, asterisk, right? You're guaranteed that you'll have enough decimal place to do everything we are going to do in this class. And that's why I chose to introduce that data type. There are other floating point data type, like the float that you mentioned here. They take less space in memory. So if you and I were working on, I don't know, like some IoT device, you know, Internet of Things project, and we had like this small device that has only, I don't know, like 4 kilobytes of RAM, then maybe we would worry about our variables, you know, taking 32 bits in memory, 32 binary digits instead of 64. Okay, that would save us some space. But other than that, in a desktop application, especially the kind of application we write in COP2512, 2513, there's really no point for us to go with a float and risk, you know, to be short in decimal precision or stuff like that. There was another question in between. So Boolean values is for logic statement, right? Yes. Logical statement in Java are going to return to be evaluated into Boolean values. Perfect. So three data type in Java: int for integers, double for anything that has a decimal part to it, numerical value that has a decimal part, and then Boolean when you want to store in a variable only one of two possible values, true or false. That's what Boolean does, true and false, nothing else, okay? The syntax to declare variable, it's int, for example, so the data type that you want. I want a variable of type int, space, the name of the variable, space equals space, and the value that you want to store in the variable when the variable is created in memory. So declaring a variable is a way to say, I want a piece of memory to be reserved to store a value of data type int. And I want this piece of memory to be accessible under the name n, in this case. And I want this piece of memory to contain 0 to start off with. That's everything that we say here. Right? And the same way that you can use the syntax here we call that initializing the variable. Okay, the first time you assign a value to a variable, you initialize it. Okay, you put an initial value into the variable. So the same way that you can say I want an int named n initialized to 0, you can say I want a double named rating initialized to 43.9. And these are statements. So I end them with semicolons, okay? I can put a bunch of them one after the other in a row. They are inside a block of code, so they are going to be executed one at a time. The moment this is executed, this first statement here is executed, then after the statement has been executed successfully, I can start using the variable n in my program. So I can refer to the name n, and it's going to correspond for now to the value 0 always, okay? All right, so we are going to set up, like I told you about this Java for now or just enough Java approach that we are going to take for module 1, 2, and 3, okay? I don't want to overwhelm you by throwing at you all the possible data types and spending 2 lectures going over like their ranges and stuff like that. I want you to get writing code fast. So we have only 3 data types for now, okay? That's it. And we're going to do that for M1, M2, and 3, and it's going to allow us to write already a good amount of different types of code, okay? I'm going to add another rule here. I'm going to say when you declare your variables, so when you use a building block 1, you declare a variable, I want you to do it at the beginning of your main method. If you have another method, you can also have variable inside that method. We're going to talk about that later. For now, just to give you like the minimum that you need to know here about the topic of having variable inside different method, okay? If I go inside the main and I say, hey, I want a int x equal 42. So I declare my variable x. That means I can display, I can use X. So for example, I could display it. Let me compile this, run it. It's going to display 42 on the screen. But if I did something like, for example, I call do something, the method do something here, right? If I call the method do something, and inside of the method do something, I do something like system.out.println X again, okay? Here's what's going to happen. It's not going to work. Cannot find symbol X. What does that mean? That means that when you declare a variable, you declare it actually in Java inside a block. So I declare this variable here inside the block of code that correspond to the body of the main method. When I try to use the variable outside that block, like in another block of code that's separate, that correspond to the method do something, it's not available. So X here is only available from the moment I declared it up to the end of the block. This is called the scope of a variable. Whether you remember that name right now doesn't matter. We're going to come back to it, okay? I'll define it formally. But this is an idea of you have to declare variable inside of blocks so that you can use them inside those blocks. But each block of code is kind of isolated from one another, okay? Can you declare initialize a variable without setting a value for it? Good question. So I can. Java lets me do that. Well, most of the time, like right now, it should yell at me. I can write, int x, and that means I want to reserve the memory to store a value of type integer, and I want that memory to be accessible under the name x, okay? But here's what happens. The first time I try to use x, because I never specified what value I wanted in x to start off with, the compiler is going to even catch it for me and say, the variable x here might not have been initialized. So it's always a bad idea to not initialize your variable. So there are times where we could get away with not initializing the variable, but what I'm going to ask you to do for module 1, 2, and 3, at least, to try to get good habits, is every time you declare a variable, you put an initial value into it. And if you don't know what to put, 0 is good for an int. If you have a double y, 0.0, if you don't have any other better initial value to put is okay as well. And if you have a Boolean flag, you can put true or false there. I really don't mind, don't care, okay? But the bottom line is we are going to always declare all of our variables at the beginning of the main method, okay, at the beginning of the block of code that correspond to the source code for the main method. And we are going to initialize them all. And the key is try to find names that mean something, okay? Like XY, like I'm using here, that's not good. Like, for example, revenue, revenue, tax rate. These are much better variable names because I just take a quick look and I know what you mean already with that variable, what you want to do with it, okay? We could always replace the value of a variable, right? Yes, that's why they're called variable. Later on, you can store inside of, for example, tax rate, the value 00, and later on, you can change that value. We're going to see that right in the next slide, okay? So variable mean they vary, okay? They change. Would you have to repeat inserting the variable in the different block if you want to use it in that block? That's a good question. I like that. Okay, so yes, but it would be a different variable. Okay, so we're going a little bit further than I wanted to go for this slide, but so be it. Let's say that here I say, let's go back to x because it's easy to type. Int x equals 0, system.out.println x, okay? I want to be able to do system.out.println x. Int x. I try to compile this. First thing, it's telling me, hey, this variable might not have been initialized. Yeah, I didn't initialize it, but it's just because I wanted to kind of, connect the two x's here. So it wants me to put something in it. So I'm going to initialize it to something different. Okay, 999.9. That's not an int. What am I doing there? Okay, 999. There we go. So I try to compile this. I have already an active compile. I try to run it, and look at what happened. So declare x equals 0. X contains 0. Declare two other variables that we don't use. Then system.out.println x. So it contains 0, right? So I display 0 on the screen. We're good. Call the method do something. So we go and execute statements that are in another block of code. So all the variables that we had here are not available. But I decide to have another variable called x. I can do that. I'm not going to do this right now. Okay, there we go, this update. But I can do that, which is redeclare an x, a variable that has the name x. This x variable here and this x variable here, they have nothing in common. Yes, they have the same name, but this one is a variable that exists inside the main. This one is a variable that exists inside the method do something. It's like the two methods have their own set of, private variables that they can use. And there is no magical connection between the two because they share the same name, okay? This is x inside of do something. This is x inside of main. So that explains that I have to redeclare it. I have to reinitialize it because it's a brand new variable. And when I display it inside do something, it displays 999. And if I went here and I said, you know what, I want to make sure that I still have my x equals 0 inside the main. So I add a system.out.println x here at the end of the main. I compile this. And this is the proof that the first println here displays 0. We call do something. It uses its own x that contains a different value and displays it. And then I display again the x from the main. It contains 0. Does that make sense? So that's the idea of, so first ID, building block 0, we have blocks of code. Second ID, inside a block of code, you can declare variable. And I'm going to ask you to do it at the beginning of the block of code, okay? And each block of code kind of guards jealousy. Think jealousy here, guards their variable inside the block, that block of code. If we want to use a variable declared in block A and block B, then should block B be inside block A? So that one I'm going to postpone, okay? Hang around like 5 minutes at the end of the class, and we will discuss more if you want. But I'm going to postpone it because this is getting a little bit more into scope again. I think we went far enough in the scope for now. But definitely, if you want to know ahead of time, hang around 5 minutes at the end of class, and I'll cover that for you, okay? So we are going to have this little rule that says always start by declaring your variable. You open a block of code, you're going to need a few variables, declare them all right there. And also, I'm going to ask you to initialize them. I already mentioned that. And I'm going to ask you to always comment the role, like I did here, okay? So that means that when you declare a new variable, for example, here, x, I could say, for example, coordinate of my spaceship. Let's say I'm writing, again, spaceship with a P. This is tax rate on revenue. And this is whether or not we need to redisplay game screen. So the point here is when I start reading the main, I'm going to see the code, the rest of the code inside the main is going to work with 3 variables. These are the name, these are the data type, these are the value, and this is an explanation of what I'm going to use that variable for. What kind of value in my application do I need to store in that variable? And if you do that, that makes your code super clear, super readable, okay? So that's why we're going to do it for module 1, 2, and 3. And then once you got some good habits in you, we're going to start relaxing a little the constraint. You're going to be able to do a little bit more what you want, okay? But at the beginning, yes, we're going to get started like that. Those values here, 0, 43.9, and true, these are values, right? These are called, just to introduce the proper vocabulary, these are called literals. We already encountered that term, I made sure of that, right? When we said system.out.println hello world, the string hello world was also a value, right? It was a piece of text, that's some data, that's a value. And I called it a string literal because it was literally written in the code. Well, the 0 here is not read from a file, is not read from the network, is not read from the keyboard. It's something that I type, it's a value that I typed literally right there in the code. So it's an integer literal or an int literal, depending on how accurate you want to be. This is a double literal. So each literal value in Java, whether it's numerical, whether it's Boolean, whether it's some text, is having also a type, a data type. And the rule is inside a variable of type n, you can only put values of type int. We are going to amend that rule, okay, like in a few weeks. But for now, for us to get started, if I try to do something like, for example, assign 0.9 to int x, look at what's happening. The compiler tells me incompatible types. And we're going to talk more about what it says here, okay, when we talk about type conversions. But right now, incompatible types. Do not do that. Do not give me a double literal and try to shove it inside an int variable. Same way, do not give me a string of text and try to initialize an int variable with it. That's not all right, okay? So the value that you initialize a variable with must have a data type that matches the data type of the variable. So you can't use decimals in int? Yep, you got it. That's exactly the deal for now, okay? For now, if I'm going to use something that represents, for example, I don't know, the price of something, I'm going to use a double. If I want to use something that's going to be a counter, like 1, 2, 3, 4, 5, up to 10, I'm going to use an int. If I have to use something that's only one of two possible values, true or false, I'm going to use a Boolean. And if I want to use something that is a string of text, well, we'll introduce that data type very soon. Okay, we don't need it right now, but we'll introduce the data type for that as well very soon. Okay. Spoiler alert, it's called string. All right, like the string that we have here, but it's a little bit of a different data type. You see that it doesn't color, it's not a keyword. So yeah, I have much to say about this. Okay. So you guys are okay so far? Makes sense? Data types, declare variable, initialize them. So that's building block 1. Building block 0, we have sequences of statements that are called blocks of code. Building block 1, inside those block of code, one of the statements can be declaring a variable. Okay, one or more statement can be declaring a variable. Building block 2. Somebody was asking, so can we change the value of a variable later on? Yes, absolutely. So here's a code example where I declare a variable n1, data type int, initialized to 0, n2, data type double, initialized to 0.0, flag, data type boolean, initialized to true. So I did all my variable declaration and initialization at the beginning of my block of the main method. And then I'm using a syntax that is very similar here, but like whereas I had to say int n1 equals 0, semicolon to declare and initialize, well, here I just write n1 equal 42. So the equal sign, a single equal sign like this, means assigning a value. When you assign a value to a variable, you put the name of the variable on the left, the equal sign, the value that you want to assign to write inside the variable on the right. And here, we did already an assignment, but because it's an assignment that we do right when the variable is created, it's called an initialization. Later on, when you don't redeclare the variable, but you just want to change its value, you write the name of the variable equal and the value that you want here to store inside of it. So a variable at any given time can have only one value. So n1, for example, can contain 0 at the beginning, but the moment that you assign 42 to it, the 0 is gone. Now n1 contains 42, right? So the variable n1 contains one integer value at a time, but we can keep changing it. For example, here, n1 contains 42 after the execution of the statement. But later on, if I do n1 equal 42 plus 3, so now I don't assign just a literal, I assign a whole expression. What does Java? It evaluates the whole expression. So 42 plus 3 is 45 and stores that value into n1. And then here, 42 plus 3 times 2, again an expression. 42 plus 3, that's 45, times 2, that's 90. So it computes the value of the expression, the arithmetic expression you put here, and then it stores the result in the variable n1. And of course, you can have expressions that are more complex, that involve, for example, decimal values, etc. Okay, not just int, but also floating point. So there was apparently a hiccup in the networking. I guess it's on my side because many people got affected. So sorry about that. But yeah, it apparently cut off for like 1 second and came back online. So I'm glad we're back online. When things like that happen, let me know, okay? Especially if you lose audio, don't let me keep talking to myself for half an hour. Just let me know in chat that something is wrong, and we'll try to fix it, okay? So I can assign values to variables that are int variables. I can assign new values to variables that are double variable, double data type. I can assign new value to variables that are of Boolean data type. But for Boolean, see, there's only two values, true and false. So you can write flag equal false, semicolon, or flag equal true, and that's all you can do with Boolean literal, okay? But you can also, just the same way that for numerical variable like int and double, you can assign the result of expression, you can assign also the result of expression to a Boolean variable. But watch out. The result of a numerical expression can be either an int, in which case you store it in an int variable, or a double, in which case you store it in a double variable. Okay, so we have two data types for numbers, int and double. The result of an expression, if the result of that expression is a Boolean, true or false, we call that a Boolean expression. And Boolean expressions are different from numerical expression, arithmetic expression, okay? Arithmetic expression, you guys all know about does, okay? This is just like numbers being added, multiplied, divided, etc. with one another. A Boolean expression, if you started already taking the discrete structure class, which is one of those 4 statements that is prerequisite, right? So you are going to take it in parallel to this class or after, right after, or maybe you took it right before, I don't know. You are going to talk about Boolean expression. And Boolean expression, they look like arithmetic expression. You can use parentheses, you can use operators, you can use operands, but look at the operators that we use. They are different, okay? So here we are using the operator lesser than. Guess what? 42 lesser than 50, there's only 2 possible result when we evaluate that expression. It's true or it's false. Is 42 actually lesser than 50? True or false? And that's why we call that a Boolean expression. So the Boolean expression are generally not going to do operation like multiplication, addition, etc. They are going to do comparison. Okay, I'm going to expand a little bit this definition as we go, but for now, this is a good starting point to kind of give you the big pictures. Okay. And in Java, so there was a question about what if I put 2 equal symbol or 3 equal symbol. Hold on to that question for one more slide, okay? Or 1 or 2. The single equal symbol is actually the assignment. I assign a value here. It's called initialization. I reassign a new value here. It's called assignment, okay? So right now, an equal symbol like that in the code doesn't mean that something is equal to something else. It means I take the value on the right-hand side and shove it into the variable on the left-hand side. Another quick advice for now, use tons of parentheses. Make sure that your expressions are clearly, they're not ambiguous. There's no problem in knowing what needs to be evaluated first. For example, if I remove those parentheses here, it's going to be 42 plus 3 times 2. Yes, operators have priorities in Java just like they have in regular arithmetic, in K12 arithmetic, right? So if I want 42 plus 3 to be done first, and then the result of that to be multiplied by 2, I just put in a pair of parentheses, and that's it. So a lot of that, you know, it's intuitive. You went through K12, you know already all of that, high school, you have been using arithmetic expression. Well, Boolean expression are maybe a little new, but that's about it, okay? So that's already building block 0, building block 1, building block 2. Building block 0, there are sequences of statements. Building block 1, you can declare an initialized variable. Building block 2, you can change the value of this variable later on. Building block 3, we already use that a lot. That one, we used it since the beginning. It's called, I call a method to perform a task. And what we have been doing nonstop since the beginning, because that's the easiest thing to do, is we call system.outprintln. So I can call system.outprintln and give, for example, hello world, so a literal value. I can give the literal value 42, the literal value 42.3 between the parentheses, and it works. I can also give the name of a variable here between the parentheses, And what it's going to do, what Java is going to do, is evaluate that variable into the value that it holds, and then display that value by calling the method system.out.println. But I can also have things that are more complex, like an arithmetic expression. And I think I've been using that already in my example. But just to make sure, for example, here I could say, instead of system.out.println x, I could say x plus 2, and then the whole thing multiplied by 5. Okay? And my shift key apparently dropped the ball on me here. There we go. Okay, so this is an arithmetic expression. Okay, if I display the result of it, it's going to tell me what are you doing, and it's right to tell me what are you doing because I still have false code here that has bugs in it. So let me kind of like remove all that junk here because we don't need it anymore. I just want to focus on displaying the result of an arithmetic expression. And that arithmetic expression uses a variable x. So to evaluate it, first I evaluate what is in x, 0, plus 2. That's the result of that. That sub-expression here is 2. 2 times 5, the result of that sub-expression is 10. So now it's just like if I ask println to display the value 10 on the screen. But instead of giving the value 10 literally, I computed the value 10 out of an expression, and it displays the value 10, and that's it. Okay, so we can do a lot of things here in the parameters that we pass to a method. For now, we can pass literal value, we can pass variables, we can pass arithmetic expression that contain themselves one or more variables, and that's good enough for now. The println, I've been using println everywhere, but there is actually a little variant of println that if you did the reading assignment, you already caught that one. The variant of print, because it was introduced in the first chapter, actually, the variant of println, oops, I'm going too fast here. The variant of println that I want to introduce is print, but without the characters ln at the end. So print like this. So what's the difference between print and println? Let's go back to hello world. Hello, all right, world. So what if I do two print statements, system.out.print, just print, hello and word? What happened on the screen? It displays hello, and it displays word right after it. So it's kind of like a typewriter. It displays hello, H-E-L-L-O, and then the cursor of the typewriter is standing still right after the O. And if you print something again, it displays W-O-R-L-D right after it. And if I can continue like that, if I keep continuing like this, it's going to just display on the same line and keep going, display more characters right at the end, wherever I stopped writing the last time I need a print. Okay? So chat window, does it stand for different lines? Yes. Print ln mean print something and then go to the next line. So println hello, print hello, then move your cursor, your writing position to the next line, and next time there's going to be a print or println, you start writing there. So that's going to look very visual when I do it. There we go. My println displays hello. The ln mean go to the next line. The next print that I have starts here. But if I have just a print, then the next print or println is going to continue right after it. If I put a println here, of course, now I'm going to have hello on one line, world on another line, and then the exclamation mark, exclamation mark, exclamation mark on its own line. And if I put a println here, what's going to happen? There we go. So I don't think I compiled it. Yeah, I use the wrong window. So print ln. There we go. Compile this again. Run it again. So here's what happened. Hello, word, exclamation, 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 and then ln go to the next line. So Java was ready to write something here on the next line. I never wrote anything. The program ended, so the line appears blank. Okay, that's it. So println, not difficult. It allows you to format things a little more easy to read on the screen, pretty much. Okay, but let's introduce it here. Why not? So the deal with those methods that we have been using all along. So building block 3, first example of building block 3 that we have been using all along. There are several examples we're going to consider, 3 of them actually. We call the method, we give it some data, The method takes the data, perform a job, so generally write something on the screen, right? It could be animate a sprite, render some 3D scene on the screen, write something to file, whatever, depending on what the job of the method is. And then we say it returns. So the keyword return, the terminology return, I need to introduce it now because it's really common, okay? You call a method. That means that temporarily you branch execution into the code of that method. You are not going to execute the next line right about now. You are going to go and find the code for that method, execute all of the lines of code inside that method, and then we say that you return back to whoever called you, which is here. The main method calls you here. And when you return, you resume execution of the main method. You get the next statement, okay? Question in the chat. It's more or less saying whatever is after that statement will go to the next line. Yeah, it's exactly that. Back to the println. Yeah, it's a good way to interpret it. No problem. So the idea of calling a method, having it execute its code, and then returning to the statement right after where we made the call to the method. That's a little bit of terminology, but we are going to use it so much that we might as well, say it right now. So I'm going to say I call the system.out.println method here, and when it returns, I'll be doing calling the system.out.println method here, and when that one returns, I'm going to be calling the system.out.println method here. Okay, that's what you're going to hear me say all the time, the kind of stuff you're going to hear me say over and over. So yeah, system.out.println, we've used it a lot because that was the only thing that we had, right? So now we're going to start widening a little our horizon. We started that already. We started writing our own method. So when I write my own method, I declare it, right? This is this, group here. So I declare my method. I put some code in it. I say, for example, hey, the method display something needs a variable value of type double initialized to 42.3. That's building block 1. And then system.out.println, I want to call a method from inside my method. Yeah, I can do that. Calling a method, everywhere you can have a statement. You can have a statement that is calling a method, right? So system.out.println displays a value and then end of my method. When I call this method, all of this code gets triggered, and then we come back here and we meet the end of the main, okay? So it's not difficult once you understand how calling a method works, and we are really going for the superficial explanation for now. But once you understand how to call a method, then when you write your method, you just know that when you call that method, all this code is going to be executed once, and then we come back here and we do whatever you have in store after that method call, okay? All right, so that's it for the first type of methods. So again, building block 0, you can have a block of statement, right? Now, what is a statement? Building block 1 tells us a statement can be I declare a variable. Choice number 1. Choice number 2, a statement can be I reassign a value to a variable. That's choice number 2. Choice number 3 can be a statement is I call a method and it does some work for me. Well, I need to add a little bit more to that one. So there is a second type of method that we can call. And like the system.out method is really nice. You call it, it does its job. You return to where you called it, do the next instruction after it, and that's it, okay? But there are some methods that act more like the mathematical functions that you learn to use in math, pretty much, okay? Like, for example, the square root. What happens when you do the square root? If I write square root of 36, okay? That's going to be what? What is it going to be? 36. Okay, wow. Brain fart here, totally. So if I write square root of 36 in an equation, it's going to be evaluated into a value, right? 6. So it's not just that the method computes, the result of square root of 36, and then, I don't know, displays it on the screen. No, the square root guys are used to use in math. It returns, but it returns a value. Let's take a look at this code here. I have a variable value, 42.3. I have a variable result equal to 0. I want to assign to the variable result the result of evaluating an expression. So this is building block 1, declare a variable. This line here is building block 2, assign a new value to a variable you already declared, okay? What's happening here? My expression here, it doesn't look like an arithmetic expression. It's not just the name of a variable. Yeah, sure, there's a name of the variable value here, but it's inside other stuff, right? So what am I doing here? I'm calling a method, building block 3. So my building block 3 here is right inside the right-hand side, sorry, of the building block 2. I call a method. I pass to that method the value, 42.3, okay? This method is going to do some work, compute the square root, and then it's going to return, but return with a value. So it's going to compute the value of the square root, but it's not going to display it on the screen. It's going to just return it. What does that mean when a call to a method returns a value? That means that the call to that method is going to be, when you run your code, replaced by the result that it returned. So instead of this math.sqrt, which, by the way, stands for square root, okay? Instead of math.sqrt parentheses value parentheses, I'm going to get, once that method is done doing its job, I'm going to get the actual value, the square root of 42.3, which I have no clue what it could be, okay? So that value is then going to be assigned to the variable result. Okay, so I saw that on chat, but I wanted to finish my explanation before I go there. So methods are basically functions. Well, in the mathematical sense, the first type of method that we looked at, the system.add_println, is not a function. Okay, it doesn't return anything. It returns, that means it terminates and you go back to whoever called it, but it doesn't carry a value with it. The method, the type of method that we're talking about, here's the second type of method we're talking about, are methods that are written so that they not only, you can call them, they execute, they do their job, but when they are finished, their call is replaced by the value that was just returned. And you can use that anywhere you would use a value in an expression. So I can do system.add_println, math.sqrt of value, right? I call the method, give it value, it computes the square root, returns the square root. The square root is now passed to println, which does its job, which is displaying it on the screen. I can use them anywhere. I would use an arithmetic expression, like, for example, on the right-hand side of an assignment. Here I expect an expression. I can use the square root method as an expression. So in Java, we still use the word method, okay? In Python, we talk about functions. In JavaScript, we talk about function. So it's a little bit different, okay? But in Java, we talk all the time, we talk about method. They are just methods that do not return anything, and there are methods that return one value. And a method can only return one value in Java, okay? So no value return, or maximum one value return. And that's it. We don't call them function, even though those type of methods are closer to the idea of function that you know from your math courses. And now we need to break out from the main slideshow a minute. So before to do that, I'm going to answer the question in chat. But now I have a few things to introduce to you, okay, syntax-wise, etc., concept, so that we can write our own method that are going to return a value. Because right now, we never learned to do that, okay? All the methods that I wrote with you guys until now, you call them, they display generally something on the screen, they do their job, and then they terminate. But they never brought back a value to whoever called them. So we're going to learn to do that. And as soon as we learn to do that, you guys are green, you are go for codingbat.com. So I'm going to start assigning you very soon codingbat.com graded exercise, because in codingbat, every time you try to do an exercise on codingbat.com, it's going to be pretty much, here's a method, write the code for that method, and make sure that it returns the right values when it's called with those and those and those parameters. So to be able to use codingbat, you need to be comfortable writing small methods. You need to be comfortable accepting parameter from the method and returning value from the method. We are almost there. We are this close, okay? So we're going to look into that right after I answer that chat question. Why didn't we give system.add_println result for the last line, since the new value of result is math.sqrt? Let me go back. Yeah, I could have done that, okay? There's no reason for which, like I could have written system.out.println, open parentheses, result, close parentheses. You're absolutely right. The only reason I wrote it like that, I recomputed again the square root value, is just to make sure that you had an example in the slide of a piece of code where I call a method, and the data that I pass to that method for it to do this job is obtained by calling another method. Okay, so it's like building block 3. This is a building block 3. I'm calling a method square root inside a building block 3, which is calling a method named println. Yeah, I knew that you just wanted to make sure there was not a trick there. So no, there's no trick. It's just me going the long way, doing it like suboptimally, just to show you, to give you an example of starting to, to put building blocks inside of building blocks. Just like here, this is a building block 2, right? Assign a value to a variable. And inside that building block 2, what I do to compute the value that I need to assign, I use a building block 3, call a method, and have it return a value. All right? All right, so let me see. Before we jump into that, actually, I'm going to do it a little differently. Before we jump into that, which I'm going to do in entirely live coding, let me show you one more thing, the third type of method that you can call. So we could have done without this one, honestly, but I want it to be thorough. So the third type of method you can call. The first one is you call a method, it does something, for example, display stuff on the screen. That's what we are going to do this whole semester. Or it could also, write stuff into a database, write stuff into a file, send a message over the network. So it does a job, but then it returns and it doesn't return a value. The second type of method, it computes a value and it returns it. So these are the functions that you know from math. But then there's a third type of method if you want to be, thorough. These are methods that you call. They are going to do some job, like, for example, interact with a network, go to a website and pull some value of a stock exchange, from a REST API or something like that. And then they're going to compute something with that value, and then they return the value. So it's a mix of both first types. It's some method that does something, and at the same time computes a value and returns it. So I'm going to stop saying method that does something. I'm going to use the proper terminology. So here's some more vocabulary for you, okay? When a method executes, and as a result of its execution, it just computes a value and return it, we call it a pure method. Pure, why pure? Because it's mathematically pure. It's a function, it's a mathematical function. You call it with a number, it computes a result, returns a result. Ideally, if you call it 50 times with the same number, it's going to return 50 times the same result, okay? That's the beauty of a pure method. It's a mathematical function. And then every other method that either doesn't return a value but displays something on the screen, or returns a value but also displays something on the screen, or I don't know, write into files, write into database, communicate over the network, all of those things are called side effect. Okay, so that means that your method is not just a pure mathematical function that computes a value and gives it back to you. It may or may not compute a value and return it to you, but it also has side effect on the rest of the world. For example, it's going to change what is displayed on my terminal. It's going to write to the console. Once the method writes to the console, that cannot be undone. This is a side effect of executing the method. Every time you execute it, it's going to write a little bit of data on my console. If I was updating a database, every time you call your method, it's going to have a side effect to the database. It's going to change what's inside the database, just like the other example, change what is in my terminal, right? So all of those methods that affect the real world or other computer system or other programs, they are called method with side effect. People that do a style of programming called functional programming try to avoid them. They call them impure method. So we have pure, almost mathematical method that return a value and do nothing else. And then we have everything else, which is most method, most of the time, they may or may not return a value, but they are going to do some side effects, have an action on the screen or an action on the printer or an action on the database or something like that, okay? So let me show you an example of that one. And this is important because we are going to introduce a new a new method that we can call. So forget about system.out.println. That was just for the first week, right? Now we're going to do some more stuff. So it's bad time, I know, for some of you. So we are going to learn to read information from the keyboard, okay? But to be able to do that, I need to leverage already building block 1, 2, and 3. I need a bunch of things, okay? So here's a code example. Class user inputs. Public void, I'm going to come back to that line in a second. Public static void main. All of that we know already. We have a building block 0 here, starting here, ending here. This is a block of code. Many statements inside of it. The first statement is declare and initialize a variable. So building block 1. But wait a minute, the data type here for S is the name of the variable. The data type is not int, is not double, is not Boolean. It's scanner with an uppercase S. So what's going on here? It's a new data type. Short story, it's a new data type that I'm introducing right now. And then the value that I assign to that data type, whoa, it's not a literal value. It's not an arithmetic expression. What is this new thing? So new is a new keyword in Java. Okay, so we are adding one more keyword. I don't know how many do we have right now, like 10, something like that already. It's going fast, huh? So we have the new keyword now, and then it's followed by the same name that we use for the data type of the variable, scanner. But then there are parentheses, like if we were calling a method named scanner, and we give something to that method, which is system.in. That looks like a name, but the name of what? The name of something that exists in the JDK, but I didn't create it myself. All right, so let's calm down a little bit. For now, this is going to be kind of like a recipe for us. What this line does, it declares a variable S. So it's still building block 1, right? Declare a variable S of data type scanner and assign it a value. That value is what we call a scanner object. So scanner is not a simple data type like int, like a number, or like a string of text, or like a Boolean. Scanner is actually a data type that represents, think of it as an entire program, okay? The code for a scanner in the JDK is the code that allows you to interact pretty much with your keyboard, but also, as we're going to learn later, to write into files and stuff like that. So it's kind of a Swiss Army knife. When you say, I create a new scanner, there's some memory that's going to be reserved. A big chunk of memory is going to be reserved. Java is going to create an object, it's called an object, of class scanner inside of that memory. And now it's kind of like you can talk to the scanner through the variable S, and you can ask it to do stuff for you. Like you can call method on the scanner, you can maybe look up values in the scanner, stuff like that, okay? So think of an object in memory as a sort of piece of code that you didn't write for now, that contains maybe some variables that you can access, that contains certainly some methods that you can call. So it's a program, it's a unit of code that's stored somewhere in memory. So I created such a unit of code here with the keyword new, and I made sure that I assign it to S so that I can access it with the variable S. There is so much more I need to tell you about this line, but one thing at a time, okay? Right now, this line declares a variable S of data type scanner and creates a scanner object to go along with S. Why do I bother with that? Well, because later on, so I'm going to declare int value equals 0, okay, building block 1. And later on, I'm going to assign to the variable value, so building block 2, assign a new value to the variable. I'm going to assign something that looks like calling a method, because there's those parentheses here after a name. S.nextInt. And then the parentheses that mean I'm calling a method. The short name of the method is nextInt. The full name of the method is s.nextInt. Is that new? Yeah. We have never done that before. We did things like system.out.println and pass value, right? But system started always with an uppercase. Now we have the name of a method that not only starts with a lowercase, s.nextInt, but the s part of it, it's a variable that we created here. Yes, you can do that. You can create objects in memory. Okay, so object things repository of methods, a bunch of methods that you can call and so on and so forth, okay? You create those in memory. You assign them to a variable s so that you can access it with the name s. And then you say, oh, I want to access the scanner that is linked to the variable s, dot, and inside that scanner, I want to use the method nextInt. So s.nextInt, the primary way that I want you to understand it is s.nextInt is the name of a method. It's the name of a method that reads from the keyboard whatever the user types until they hit the enter key, okay? But that name is going to change from program to program. For example, if I go in my code here, and I'm not ignoring the chat, okay? I'm just trying to go up to a point where I can interrupt and the flow is going to be logical. If I go in this program here and I say I want a scanner S equal new scanner. So this, I'm going to ask you to kind of learn it by heart for now until we can break down all the pieces, okay? So scanner S equal new scanner system.in. So that means create a new scanner that can read whatever the user types on the keyboard and let me access it with the variable s. So later on, you can do things such as s.nextInt. That means read an int value from the keyboard. And this is going to be a method call that does something, reading whatever is typed, and returns the value that was typed. So I'm going to store that value, for example, in x, okay? So that's new. That's a new way of doing things. But that's what's going to happen, right? Progressively, we are accelerating a little bit. We are adding more and more keywords, like we are 10 plus keyword. We are adding more and more recipes. But you can still get away with memorizing those things as recipes, okay? This is how you create and initialize a scanner named S. And this is how you use the scanner S to read the next integer from the keyboard. When you look at it like that, it's like, sure, why not, right? What happens if I try to compile this? Java is going to tell me scanner. I don't know what a scanner is. So line 14, right? Right here, the hat symbol tells me when I encounter the word scanner here, I don't know what a scanner is. We didn't have that problem with math.sqrt or system.out.println. So here's the deal. System.out.println, math.sqrt are methods that are available from the JDK that you install. So when you install the JDK, you not only installed javac.exe, java.exe, those two commands that we saw that serve to compile and run respectively the code that you write, but you also installed a bunch of code that is pre-written. And we have been able to already deep into that resource by using system.out.println and now math.sqrt, okay? But there's so much more. But the deal is when you write a new program like this, Java is not going to include everything from the JDK into your program. It's going to give you like what's considered the minimum that everybody uses all the time. So system.out.println, the square root method, yes, these are considered minimum stuff. And then a scanner, well, not every program has to read data from the keyboard. So this is where the engineers at Oracle drew the line, and they said, no, I'm not going to allow you to use the scanner by default in your Java program. However, if you want to be able to use the scanner in your Java program, just let me know, and I'll import the code for the scanner inside your application. So import java.util.scanner, semicolon. So that's a statement. That's a weird statement. That's the only statement that we learned so far that lives outside a class. It's actually the first thing you need to do in your code. Okay, so even before you do your comment here, like the author, the date, the goal of the program, you are going to have all of your import statements, and there can be multiple ones that are going to be here. Okay, and in this case, what do? Again, that you have to memorize. Okay, you want to say, I want to be able to use a scanner data type in my program. So I need to give the full name of the scanner, which is where to find it in the JDK. So it's inside what we call a package named Java, inside a subpackage named util for utilities, and then it's scanner. And when you say import java.util.scanner, you allow yourself to use the word scanner anywhere in your code. So now when I try to compile, Java is going to say, oh, scanner? Yeah, I know what you mean. I know exactly what you mean. When I run this, here's what's going to happen. This is stuff that I type. The program is going to execute the main, declare this variable, declare this variable, declare this variable, create a scanner, and when I execute next int, my program freezes. What is it doing? It's waiting for me to type a number. Type a number, an int, enter, and it read it. So of course, this is not really great because it just read and do nothing with it. So let me add a little bit of decoration around. Enter an int value. Okay. I display what we call a prompt. I tell the user what to do, and then I'm going to say system.out.print. You entered the value, and system.out.println, and I'm going to display whatever x was. So I ask the user to enter a value. I read the keyboard and wait for them to type a value plus enter. When they hit enter, I read that value, shove it into the variable x, and then I can use that x variable everywhere I want. Let's see it run. And then I'm so sorry, but I know I have 2 questions pending in the chat. I'm coming. Okay, don't worry. I'm not ignoring you guys. So enter an int value. Let's say again 42. I hit enter. You entered the value 42. Okay, and if I put a space here, it's probably better. There we go. But bottom line is that I read something from the keyboard, and I use it after that to do something else in my code. Okay. All right, is that a good time for me to, let me check if I covered everything on this side. We need that import statement. We need a variable that's going to be our scanner. Then we can use that variable to actually trigger some methods from the scanner that do something like reading stuff from the keyboard. Yes, we are done. So now what I have to do is what I promised you I was going to do to prepare you for coding that. But before I jump into that, question from the chat. Does the scanner variable always have to be named as? Good question. Very good question. No, it doesn't have. For example, here I could call my scanner SC. Okay, but if I do that, watch out. Now I need to use SC dot something. Okay, most of the time I see students calling this input because we want to read some input from the user. So there we go. You compile this, it's going to work just fine. Does the import Java util scanner always have to be outside of the class? Yes. Yeah, it has to be the first thing that you do in your Java file. So here you say, I want to import this. I'm going to need those tools. So you are telling pretty much the compiler, I'm going to use this and this and this and this tools that are available right now from the JDK. Okay? All right. How is that sitting with you? Does that make sense so far? Did we cover too much material? You have like, if you don't want to type in the chat window, you have on your, if you click on the bottom left button of your window, the one that shows your profile, you can click on things like, for example, happy, surprise, faster, slower. Okay, don't hesitate to use that during the session as well. Like, for example, let's do a quick poll here. How many of you right now are okay with the content that we covered today? Okay doesn't mean that you are ready to jump in and write your own code. Okay just means that, okay, if I listen to the lecture one time or reread the slides, I'm going to be able to process that. Not okay means I'm overwhelmed. I need help. Okay. So use thumbs up if you want, or use those icons like I told you, you know, in your contact profile here. You can say confused and stuff like that. And I just want to get a sense, you know, of whether I'm going too fast, pretty much, or not. Okay. So I see only positive right now. Okay. So that tells me I'm not killing you guys. I'm not going too fast. It's easy. So awesome. If you are not saying anything because you feel, oh, everybody seems to be okay with it, I'm not going to, you know, put the spotlight on myself, then don't type anything in the chat window, but hang around 5 minutes at the end of the session, or come to office hours, okay? Because we are going to keep piling more information on top of this. So it's very important that you get this, whatever we talked about today. It's very important that before next lecture, you have that assimilated. So you are going to review the video maybe you're going to just reread the slide, do whatever it takes, but make sure that you come next lecture with that building block 1, 2, and 3 understood. And use office hours if you need to. That's what they're there for, okay? We'll re-explain to you until you get it, but don't wait, okay? Next lecture, we build up of that, okay? And I will do next lecture the coding bad stuff because we are a little short on time. So I'm going to cut it off right now for today. As usual, thank you for your attention, patience. Could I scroll down to the scanner code real quick? Absolutely, no problem. Here, let me make this smaller so that you can see more code. There we go. This is the scanner code that we wrote together. Okay. So let me know if you want me to scroll back up or stuff like that. But I'm going to stop the recording. Thank you again for your attention. And what are we? We are Wednesday. So I will post an announcement for the next session, but we are going to 99.999% sure be face-to-face for the next session. Okay, but I will post an announcement so that you have something in writing. Okay. All right. Bye, everyone. Thanks. Have a good one.